All right, graphing quadratic inequalities. Students will be able to interpret solutions in the context of the situation model and decide if they are reasonable. All right, to graph quadratic inequalities, you graph it like you normally do if it's just a regular quadratic equation. In other words, if it was just an equals instead. All right, so first thing you do is find the vertex. So let's see here, vertex. So we use the net. See, this is in standard form. So we got to do the negative b over 2a. So first of all, a is equal to -1, b is -4, c is 0. So negative b over 2a, so it becomes positive 4 over 2 times -1. And you get -2. So the x-coordinate of the vertex is at -2. Take -2, plug it back in. So we got -2 squared minus 4 times -2. This right here tells me I have a negative on the outside of the parentheses, so no matter what, my answer will always be be negative. So 2 squared is 4, so it'll be -4. And we get plus 8, so you get positive 4. There is my vertex. So I plot that. -2, 4. And immediately, I'm going to draw my axis of symmetry right down through that vertex. All right. So when I plot another point, I know to reflect it over the dotted line. Right? That way I will not be moving this point. A lot of people have a tendency to flip this, which is the vertex, and you end up getting the graph wrong. All right, and next, since this is the standard form, my y-intercept takes on the form of 0, c. Well, it will always be 0. C in this case is 0. So my y-intercept is at the origin. Okay. Now, see, this is on the side, on one side of the dotted line, so the distance from here to the axis of symmetry is 1, 2. So that means I'm going to go a distance of 2 on the other side. 1, 2. So I'm at -4, 0. Now, that right there stays the same. Now, this is where, since it's an inequality, things get a little different. All right? So, first of all, you look at the inequality. Is it just less than, greater than, or is it less than or equal to, or greater than or equal to? In other words, does it has it equal with the inequality or not? This it does not, so that means I make a dashed curve. Okay. Well, that means if the point is on the curve, it will make the statement false. In other words, y will still be equal to that value, and we want it to be less than. All right. So a dotted line takes care of that. Then the second part. All right. Excuse me. So this is a dashed curve. If it does have equals with it, then it's a solid curve. So that's one part of graphing inequalities. The second part is shading. All right, do I shade inside or outside? That's what we have to determine. All right. To do that, we use a test point. Now, in my case, I like to use the origin, right? But you notice it's already taken. All right, so you need to pick another point. You can pick any point you want. I like to pick a point somewhere close to the origin because it makes plugging it in makes it a lot easier to work with numbers. So I'm going to use, this is my test point. All right, so you do the same thing. Put a little mark where your test point is. So that test point is at, so the test point I'm using is at what? -1, 0. So I'm going to plug that into this equation and find out if it's true or false. So I'm going to have y, well, y is 0, less than negative 1 squared minus 4 times negative 1. Remember, negatives on the side of the parentheses, so this always will be a negative. So this is negative 1, that's positive 4. And negative 1 plus 4 is 3. Now ask yourself this question. Is 0 less than 3? Yes, that is true. 0 is less than 3, so that's true. So that means you shade where the test point is. Here's the test point, so that means it's on the inside. It was true, so I shade on the inside. Okay, that's how you graph quadratic inequalities. All right, let's do a couple more examples. Okay, standard form. So first thing we do is find the vertex. So A is 1, B is 2, C is negative 8. So we do negative B over 2A. So it becomes negative 2 over 2 times 1. So negative 2 over 2, which is negative 1. Plug negative 1 in, so we got negative 1 squared plus 2 times negative 1 minus 8. That becomes positive 1 minus 2 minus 8. So that is, what, 10 minus 1 is 9. So it would be negative 9. Right, so this is my vertex. So I'll plot that point. Negative 1, negative 9. Immediately draw my axis of symmetry. Next, I plot my y-intercept. In this case, remember x will always be 0, and whatever c is negative 8. So there's my y-intercept. So 0, negative 8, and I reflect it. So there's distance 1, so distance of 1. Now, part 1. Okay. It is greater than, there's no equals, so that means it's a dashed curve or dotted curve, whatever you want to say it. Okay. Okay. Now I work on shading. All right, so my test point, I'm going to use, let's see, I'm going to use the origin. Right, so there's my test point. I mark it there. So I'm going to put 0, 0 as my test point. So I'm going to plug 0 for y. So that'd be 0. Greater than, x is 0, so that's 0 squared plus 2 times 0 minus 8. So that's 0 plus 0 minus 8. And I get negative 8. Now ask yourself this question. Is 0 greater than negative 8? Is 0 bigger than negative 8? That is true. So that means I shade where my test point is. My test point's here, so that means I shade inside because my test point was inside. Okay, and that's how you do that one. Let's do another example. This will be our last example. Hopefully this should be good enough. All right, standard form. So I'm going to use A is equal to 2, B is equal to negative 3, C is 1. All right, so negative B over 2A. So it'll be positive 3 over 2 times 2, which is 3/4. Oh, we got a fraction. 3/4, that's 0.75. I like to convert this to decimal because I'm graphing. All right. So 0.75, that's part of my vertex. And I'm going to plug that in to here. So it'll be 2 times 0.75 squared minus 3 times 0.75 plus 1. You can use the graphing calculator. Put it in just the way it looks. We got 2 parenthesis 0.75 parenthesis square minus 3 parenthesis 0.75 parenthesis plus 1. I get negative 1.25. So negative 0.125. So there is my vertex. So let's approximate that. Negative 0.75 is almost to 1. Negative 0.125 is just below the x-axis. So it's approximately somewhere in there. And then I immediately draw my axis of symmetry. Alright, so then my y-intercept. Well, remember, x will always be 0, and c in this case is 1. So 0, 1, so there's my point. Now we're reflected, so it's 0.75, so I gotta go 0.75, so it'll be approximately in there. Now, part 1, is it dashed or solid curve? Well, it has an equals, so that means it's a solid. So it's just a normal quadratic, like what we're used to seeing. All right. So that means, since it's solid, it has equals. That means if I pick any point on this curve and plug it in here, this thing will always be true. In other words, y will equal to whatever this is. Right? If it's on the, so let's find out, do we shade on the outside or inside? Now you notice I am going to use the test point again. So my test point I'm using is the origin again. I always like to use that whenever possible. It makes it real easy. So I'll plug 0 in for y. 2 times 0 squared minus 3 times 0 plus 1. Add 0, 0, and 0 minus 0 plus 1 is just 1. Now, is this true? Is 0 smaller or less than or equal to 1? It's true. All right. So that means I shade where my test point. My test point is on the outside, so that means I shade on the outside. Okay. Now, if my test point is false, then what you do is wherever the test point is, you shade opposite. So if this was false, then I would shade on the inside because it'll be opposite, because the test point was on the outside. Opposite means I would shade on the inside. So true means wherever the point is. False means you shade opposite of where the point is. In this last example, all right, we have this in standard form. So a is equal to -1, b is 4, c is 2. So negative b over 2a. So it becomes -4 over 2 times -1. So that gives me a positive 2. Plug that in, so it'll be negative, there we go, I can't talk. Square plus 4 times 2 plus 2, parentheses, negatives on the outside, so it will be -4 plus 8 plus 2, so that gives me 4 plus 2 is 6. So there is my vertex, 2, 6. All right, drawing my axis of symmetry. Y-intercept would be 0, c is 2, and reflect it over. All right, is it dashed or solid? First question. In this case, there's no equals, so it's dashed. 2, now I shade. Okay, so I'm using a test point. My test point will be the origin again, so I'll mark it. All right, so I'll plug that in. So it'll be y is 0 less than -0 squared plus 4 times 0 plus 2. 0 is less than, that's all 2. Is this true? Is 0 less than 2? Is 0 smaller than 2? Yes, that is true. So wherever my point is on the inside, so I shade where the point is. So I shade on the inside because it's true. If it was false, I would shade on the outside because that would be opposite of where the point was.